In this demo, we're going to walk through an AI-powered banking app built on SQL database in Fabric. Before we break anything down, I'll start by showing you the final experience so you know exactly what we're working toward. The app itself is a simple, everyday banking tool. You can review recent transactions, move money between accounts, and handle your usual day-to-day tasks. There's also an analytics page where you can explore your spending patterns, browse categories, compare income and expenses, and get a clear snapshot of your financial activity. And, of course, the highlight is the AI banking assistant. You can ask questions like, "Show me my spending from the last 6 months." And it answers your questions or provide guidance with insights derived from data. Moving on, I'll walk you through how we built this app step by step, leveraging new and existing capabilities of SQL database in Fabric, integrating seamlessly with the rest of the Fabric ecosystem, and using native vector and embedding support to power a RAG solution. First off, let's go to the Fabric workspace. All you need to do is search for SQL database, give it a name, and Fabric provisions everything in just a few seconds. Right away, it will take you to the query editor with user-friendly experience that makes it simple to ingest data into your database, use T-SQL templates, open the database in your favorite tools, create GraphQL APIs, check performance, or launch the Sidecar Copilot chat. On the left, you'll see the Object Explorer. It's empty because we've just created this new loyalty database, which supports the AI app you saw earlier. Let's say we want to add a new table. You can use natural language to ask Copilot to generate that for us instantly, making schema creation incredibly fast and easy. That's the basic setup. You've just seen how quick it is to get started. Now let's look at 3 simple ways to join data across different sources in one lake. I'll start in the query editor of our banking database. Here, I can easily switch over to the SQL Analytics endpoint, which is the read-only copy of your transactional data living in one lake. In the Object Explorer, you'll notice I've added multiple analytics endpoints. These represent the 2 databases that support the AI app you saw earlier. The banking database, which handles transactions, and the Agentic app database, which stores chat history and agent events. From here, I can use T-SQL or even Copilot to query across both SQL Analytics endpoints just like a single system. Sometimes you need to go beyond your current workspace. Maybe pull in raw data files or connect to data stored elsewhere in one lake. That's where external tables and OpenRoset come in. You can think of an external table as a shortcut from your SQL database to any Parquet datasets or CSV files stored in one lake. All I need is the ABFS path. With OpenRoset, I can do quick, ad hoc exploration. With a file format right in T-SQL, I can immediately start querying that data. From there, I can join those results with existing SQL tables, or wrap them in views and stored procedures to power downstream ingestion pipelines. Once an external table is created, it also shows up in the Object Explorer, making it easy to find and work with. Finally, let's look at a third approach, using Data Agent. A data agent acts like an intelligent conversational layer over your data using AI. You can define instructions and sample queries, connect multiple data sources like analytics endpoints, lakehouses, semantic models, and more, and publish it so others can use it to get answers to their questions. Here, I already connect some databases in my data agent. So, instead of writing SQL, I can simply ask, "Are there any correlations between chat sessions and transactions?" The data agent automatically determines which sources to join and returns the insight. With Fabric, we're also bringing modern application lifecycle management practices to your databases, making it easy to put every database under source control. Here in my workspace, I'm going to click Source Control. Fabric automatically detects the new database and external table that I created. I can commit them directly to my Azure DevOps. When I open the Azure DevOps repo, you'll see those changes captured as code artifacts. Every object in the database can live right alongside your application code. Let's switch over to Visual Studio Code. Here, I can see the same updates synced locally. From this point, I can start making new changes like adding a new rewards catalog table. With the MS SQL extension, I can connect directly to my SQL database in Fabric from VS Code. The new Fabric Browse experience in the connection dialog allows me to easily find my workspace and connect to any SQL database or SQL Analytics endpoint. Once connected, I can browse objects in the Object Explorer, run queries, and even create new tables using the Table Designer, along with a range of features that allow developers to work with data seamlessly. The real power comes from combining all of this with GitHub Copilot. Once I'm connected to the Loyalty App database, Copilot automatically understands the schema and relationships, so it can return fully contextualized responses. For example, if I ask it to create a new rewards catalog table, it generates the correct structure in seconds. Earlier, we committed changes from Fabric into source control. Now, I'll show the opposite, taking code changes from source control back into Fabric. With Agent Mode, you can go even further. It doesn't just answer questions. It can execute multi-step tasks end-to-end. It can inspect T-SQL or ORM code, validate it against best practices or custom constraints, and even help deploy changes to the right targets. In this scenario, let's say I'm happy with a new table definition. I'll save the file, commit it to my local repo, and push the update to Azure DevOps. Let's go back in the Fabric workspace. You'll notice that Fabric automatically detects that update and syncs it into my workspace. With that, we've come full circle, authoring database objects in code, committing them through standard DevOps workflows, and seeing those updates inside Fabric. Let's switch gear and talk about the other capabilities in SQL Database. If we look at the settings, you can see options like Microsoft Information Protection labels, endorsements, and connection strings. You can also see the backup retention policy. We now support up to 35 days. We also have support in public preview at Ignite for customer-managed keys at the workspace level. Additionally, you have the ability to manage whether Copilot auto-completion is enabled. Going a bit further into the experience, you'll see features like shared queries, where workspace members can all view, edit, and run this query, enabling collaborative development and knowledge sharing. Here, I'm checking details about my customer-managed keys. You can also monitor data replication to OneLake and configure various security settings. For example, this section is focused on managing security roles. There are different roles available by default, but you can also add custom roles. Let's say, for my application, I want to add a role that only has select permissions, and let's name it as Loyalty Select Role. Now, I can actually manage access to this role. I could give access to an application, or in this case, I'll give access to Idris for demonstration purposes. Once that's done, we can set up the custom roles we want. Additionally, we're introducing auditing, which is in public preview at Ignite. By default, when you turn this on, everything is audited and kept forever. However, you can customize this. You can choose which action groups are audited, how long logs are kept, and even set predicate expressions. We're making these options available for you. Just a quick note, this is all SQL. You can look at the logs using T-SQL. You can also use the OneLake File Explorer. You can go into the audit logs and find those XCL files. If you're used to reviewing SQL audit reports using Excel files in SSMS, you can do that here as well. We're really giving you options when it comes to SQL auditing. The next thing I want to cover is monitoring the performance of your database. We provide a performance summary with alerts and a high-level, 10,000-foot view of what's happening right now and over the past 24 hours. You can also look into more details. For example, you can set the time interval and see how many vCores are being used over time. You can dig into queries. You can favorite queries, look at query IDs, and for individual queries, see how often they've been run, how long they usually take, and any changes in their execution. You can compare performance over time. You can even open a query in your tool of choice for further analysis and updates. You can filter queries based on what people typically want to filter on, especially when building your application. This helps you move from insights to action much more quickly. These are some of the different views we provide to help you see what's going on and whether your database is scaling or hitting any limits. The last thing I'll show is around time intervals. They stay consistent across the views you select. So, if you want to dig into a specific area, like which automatic indexes were created in the past 24 hours, you can do that. Finally, I want to show you the direction we're heading. If you have a slow query, you can use Copilot to help optimize it. Copilot can help make queries run faster. The direction we're continuing to push is integrating these AI experiences into your performance dashboard and alerting system. This way, you can move from insights to action even more quickly. Moving on, let's show you a demo of how we use SQL database in Fabric to build an AI app from the ground up. Here's an FAQ which answers common questions about the Secure Bank's products and services. Let's first use the T-SQL AI function, create external table, to register an external AI model inference endpoint within my database. This object contains information about the location, the authentication type, and specifically which model we're going to use. In this case, we're going to be using the text embedding ADA model, which I pre-deployed in Azure AI Foundry. The first step in this process is using a data pipeline to copy data from blob storage into the lakehouse. I've already loaded the PDF file here, so whenever a new PDF lands in the storage account, it triggers the data pipeline and copies the file into a specific lakehouse. You can see how that works in this Fabric Notebook code snippet. Next, we use a user data function in Fabric to extract all the text from the PDF using the Azure Document Intelligence service. This service provides pre-built models, so you can start adding intelligent document processing within minutes. We then create the necessary database objects, including the table that stores each embedding. Embeddings are vector representations of the text, which are ordered arrays of numbers, typically floats, that captures the semantic meaning of the text. We will then take the full document text, use AI generate chunks to break it into smaller text chunks, and then applies AI generate embeddings to create semantic vector embeddings for each chunk. Here, what it's trying to do is inserting the document location, generated embeddings, and text chunks into the table. We will then review the data to see the content and how it's been segmented by running a simple select query in my database. Next, let's see how we can use these embeddings with a vector distance function, cosine similarity, to retrieve the most semantically relevant text chunks in our table. And then we'll build the LLM payload with our system instructions, the context, and the user's search text. Finally, we call the REST endpoint, sending that payload to the model, GPT 4.1 in this case, and capturing its response, which the stored procedure returns as the final RAG answer. Let's execute the stored procedure using the search text. For example, I'll ask, what types of credit cards are available, and specify the APRs. The system scans the documents, identifies the context, gathers the different credit card types, and assembles the answer here. You'll also notice that each chat session is automatically written back into the table for tracking and analysis. Since all your data lives in one lake, it's incredibly easy to connect your SQL database to Power BI. And with Power BI Copilot, I can instantly generate an executive summary that highlights trends and even anticipates the kinds of questions leadership is likely to ask. You can also monitor the health of the tool itself, surfacing insights like how often the transfer money feature is used, how frequently users search documents, and where any errors occur. This gives you a clear view of feature adoption, user engagement, and overall reliability. In the usage tracking, you can also see the number of tokens used for AI-generated responses, which helps provide clear cost insights. Together, these insights help you understand not just what your users are doing, but how your AI assistant and application are performing end-to-end. Before we wrap up, let's take a quick look at how this ties into real-time intelligence, or RTI, integrated through the new change event streaming, currently in private preview. With change event streaming, these stored procedures publish table changes as events that RTI can immediately consume. Imagine you're an analytics lead at a bank. Every transaction and customer interaction streams live into Fabric. Our TI continuously monitors this data for anomalies like unusual transaction patterns or potential fraud, and when something suspicious occurs, it can trigger alerts or automated actions in real time. All of this happens seamlessly, without complex ETL or batch jobs. The result is faster fraud detection, stronger compliance, and a safer banking experience for your customers, all within Fabric.